Can you hear me in the back? Yes, everybody? All right. Well, thanks for coming to the session. It's last day, so I know all of you are kind of ready to go back home. And thanks for coming to the 5th floor. I know it was a lot of stairs, so appreciate that. My name is Luis Vargas. I'm a program manager on the SQL Server team. I've been with SQL and Microsoft for almost 7 years. I work on different distributed systems areas. I work for a long time on high availability, so anything related to always on, failover clusters, database mirroring, log shipping, things like that. And then around 2 years ago, I moved, as everybody's kind of moving into the cloud, like I moved into the cloud a little bit too. So I started working on what is called, or we call hybrid scenarios. I don't know if in general the industry uses the term. But the idea is we know that many of you are not moving today or maybe next year to the cloud, right? Some of you are going to take some time. But we still want to see what are the services that we can offer you from the cloud, right? You can still keep your SQL servers running in your own on-premises environments. But there is a lot of good services and a lot of good resources that are available in the cloud, in Microsoft Azure, and we want to see what can we offer you and what can satisfy for your requirements. So we started this around 2 years. We actually released the first set of features in SQL Server 2014. So today we'll be talking mainly about 2014, but in some of the slides we'll talk about the next version of SQL, SQL Server 2016 as well, and what are the things that are coming as part of these hybrid scenarios. If you have any questions, just feel free to ask. I think it's probably better if you come to the mic so that everybody can hear. Just interrupt me, that's fine. You know, the main idea is I want to make sure that you understand the scenarios, the technologies, and how can you benefit from them. All right, if you get something out of the session today, I hope that is this SQL Server already integrates some cloud services. These are services that offer benefits from the cloud to your own on-premises environments. And we provide these end-to-end experiences. And we'll talk about some of those examples. But the idea is, because Microsoft basically offers both SQL Server and Microsoft Azure, we have two teams that are working together. We collaborate all the time. And because of this, we can provide these experiences end-to-end. So from within SQL Server, you can do a lot of cloud stuff. And we'll see some of those examples. And you can do this using your same interfaces that you use today. So you use T-SQL or you use PowerShell, or Management Studio. You can continue using this. All right, so just making sure that everybody has the same definition of hybrid cloud. Again, the definition may change from different vendor to vendor, but basically what we look at is an environment that combines resources that come from the cloud and resources that come from your own company or corporation. We have different types of resources. You have machines, like servers with memory, CPU. You have virtual machines, right? So in the same physical server, you can have tens or hundreds of virtual machines. Storage, so you can have a SAN, or you can have cloud storage. You can have domain controllers. So you have Active Directory, for example. You have a lot of resources there, logins, policies, et cetera. And you have databases, right? You can have databases on premises. You can have databases in the cloud. If you start combining all of these things, you get into this hybrid cloud environment. There are two types of hybrid cloud that we can look at. One is you have your SQL Server running on premises, and you use resources from the cloud. Or vice versa, you have your SQL Server running in the cloud, and then you use resources from on-premises. So today, most of our customer base is on-premise, and that's why we're going to be focusing on the first one. So you have your SQL Server on your on-premises environment, and you're using some resources in the cloud. Right? And we have just a couple of slides for the other one at the end. All right, so let's talk about what cloud resources we can use. Mainly two. I mean, there are more resources. We're adding always more. But right now, the most interesting ones from the SQL Server perspective are Azure Storage and virtual machines. Azure Storage basically means you have storage that is hosted by Microsoft Azure in the cloud. We provide unlimited storage, so you can have as much as you want. We guarantee that there isn't any data loss when you store your data in Azure Storage. And the way this works is we have 3 copies of every disk. So for every data that is written to one disk, we have a quorum-based mechanism. And basically means as soon as we have majority of 3 of these disks writing the same data, the same block into the disk, then we return to the client, right? So that means that we'll always guarantee that at least you have 2 out of the 3 copies, right? And eventually the other 3rd copy will have the write as well. So we always have these 3 copies. Optionally, there are 3 remote copies that you can specify. So I'll show you this in the demos. When you configure Azure Storage, you can say, I want 3 local copies, but I also want 3 remote copies. And that means we're going to create 3 remote copies in a different Azure data center. So for example, if you're storing your data in, say, the West US region, we're going to have 3 copies in the East US region. And this protects you from disaster, for example. Right. The data is highly available. We have a concept called automated disk healing. What this means is every time that we read or write from one disk, we continually verify the checksum of the disk. The checksum is basically a digest or like a watermark that we write on the disk. And every time that we write it, we verify that the whole disk is logically consistent with that. If for any reason there is some corruption, which can be physical in the disk or logical on the write, and the checksum doesn't hold anymore, the checksum is not valid, then we automatically discard the disk. We consider it as corrupted, and we start another copy in Azure Storage. And again, you always have 3 copies of the data, right? And all of this is transparent from your perspective. If you try to read from one disk and the disk is considered corrupted, then we'll automatically reroute the read or write to a different disk, right? So all of this is under the covers. You don't have to look into that. Very low cost. There are different types of storage. I'll show you that. Basically, depending on the number of IOPS and bandwidth that you get, how many bytes per second you can write and read, it can be cheaper or more expensive. The one in the middle is around 2 cents per gigabyte per month. Right? So you can calculate based on your database size, for example, how much would that be. The other resource, Azure Virtual Machines. So this means virtual machines that are hosted in Azure. Right? So we can have, we actually have hundreds of thousands of virtual machines that we host for our customers. And you can create these virtual machines using one of the gallery images that we provide. So we have many images already available. This comes already with Windows installed, SQL installed. We have some for SharePoint, et cetera. Or you can create your own images. So you can have, you can use Hyper-V, for example, and you can generate a VHD, which is kind of a template for your virtual machine. And then you can upload that to Azure and then provision virtual machines out of that VHD. Just in the SQL side, we have 3 versions. We have 2008 R2, 2012, and 2014. We have Web, Standard, and Enterprise. And every time that there is an important security hotfix, or every time that we release a CU, we automatically patch these images. So we guarantee that the time that you go and provision a virtual machine, this comes with the latest security hotfixes and the latest CUs for both SQL and Windows. On the same day as we release a new version, so as soon as we release SQL Server 2016 CTP, like the candidate to production, on the same day it will be available on Azure as well. So if you want to try it, easiest way to go and try it, you just go into Azure, provision a machine, and you can do it. We have different sizes. You can change the sizes of the machine. The smallest one is very, very small, just 1 core and 2 gigabytes of RAM. Can be less than 1 terabyte of data if you want. And it can go all the way to 32 cores and half a terabyte of RAM and 32 terabytes of data. So it can be very, very big machines. You can change the sizes. You can start with a small one and then move to a big one or vice versa. It takes around 10 minutes to change the size. And again, it's very highly available. Similar to the concept of disks, these virtual machines are running on the host, on Hyper-V. Hyper-V is continuously verifying that the machines are running and healthy. There is also a heartbeat mechanism between the hosts. So if one of the hosts, or actually a quorum of hosts, detects that another host is down, we'll automatically detect that. And all of those virtual machines move to a different host, right? And all of this is transparent again. So we guarantee that the machines are highly available for you. Again, cost depends on the size of the machine and the version of SQL. So enterprise is more expensive than standard, standard more expensive than web. Give me just one example. For SQL standard, this could be like 2014 SQL standard, running on a 4-core machine with 8 gigabytes of RAM is 70 cents per hour. Right? You pay per hour, so if you only use the machine 2-3 hours to do some tests, you only pay for that. Right? No more than that. Any questions so far? Good? All right, so how can you access these cloud resources? You can either access them over the internet, so you can go and create what is called public endpoints, which basically means open a firewall to your virtual machine over the internet. Once you open the firewall, you can connect to, you can RDP to the machine, right? Or you can connect to SQL, like 1433 port by default. You can change the port if you want. And all of the communication is free, so everything goes over the internet. You don't have to pay for that. Or if you want to have a secure channel between your environment and Microsoft Azure, you can configure a VPN tunnel, right? A side-to-side tunnel. You can use any VPN device that you have today. I'll show you that in the demo as well. So if you have like a Cisco device or Citrix device, F5, et cetera, you can configure the device. Or you can just do it through software. So if you're using Windows Server, there is a feature called Routing and Remote Access Services, RAS. And you can go and configure the tunnel using software as well. And the tunnel is going to be encrypted, so all the communication between your environment and Azure is going to be encrypted. We support 2 encryption algorithms, iKey and AES. In terms of the bandwidth, again, the bandwidth is going to range based on your network infrastructure. Just based on the majority of customers, it's around 10 megabytes per second. So if you just calculate over longer times, it's around 600 megabytes per minute. It's around 35 gigabytes per hour. Right? Like that's how much data you can move between your on-premise environment and Azure. And there is a cost associated with the tunnel. It's 19 cents per hour as well. Right? So just giving you some ideas of how you can go and access these resources. All right, so let's look into some of these resources. Yes?
Are we going to be talking about IaaS or PaaS?
We're going to talk about IaaS mainly. So the question is, are we going to talk about IaaS or PaaS? Well, in reality, we're going to talk about on-premises, like your server running in your environment. And these resources, like a storage, is not IaaS or PaaS, it's just a storage. And the VMs is IaaS. Right? All right, so I'm loading the Microsoft Azure portal. So just going to show you some of these resources. All right, so anybody has used Azure already before? Yeah, most of you. All right, so it's a nice portal. It gives you the health status of all the regions. And you can see all the regions that we have. We continuously open new ones. This year we opened one in Brazil. Last year we opened some in Japan, and we'll just continue adding some data centers. So let's say, what do we want to do? Let's say we want to create a new storage account. So we go into new, right? This remembers the things that I have done previously. So I already have storage here. If I haven't done it, I go to data and storage, and then I click storage. All right, and the first thing it will ask me is the name of a storage account. It's just an identifier for me. When I get my build, I'm going to see $20 associated to this storage account. So I know. So I just give it some name here. Pricing tier. So this is the different types of storage that you can get. We talked about the number of replicas before. So this is the cheapest one. Right? This gives you just 3 replicas in one data center. Or you can have the U-redundant, which gives you 3 more replicas in a different data center. Or we have the read access U-redundant. And what this allows you to do is, besides of being able to read and write on the primary data center, you can also read the copies on the secondary data center. So this is useful, for example, imagine that you're storing your backups. And for some reason, you want to go and create virtual machines let's say you store the backups in West US, and you want to create virtual machines with databases out of those backups in East US, you can just use the read copy on the other data center. So you select the one that you want. This resource group is just an identifier for resources. So we talk about these resources in cloud. So you can have like a storage account and some virtual machines and put them all part of the same resource group. So you'll see your billing. Like when you're charged, you'll see how much money associated with the resource group. You can stop the resource group so that all the resources go down, or you can start them. So it's just for management. Location, so where in the world do you want to store the data? So you have Asia, East US, West US, Central US, Europe. And your system administrator, your subscription administrator can specify where you can store, where you can create some of these things. So if for some reason your admin doesn't want you to go and store data in Japan, he can go and block some of this. And this is why some of these are blocked. So let's say I select West US. And that's it. At that point, you click create. And what happens is you get one of these, like this one, storage account. And this storage account will give you some information. So for example, these endpoints, we talk about the endpoints. These are the ways how you can connect over the internet. So I have a primary endpoint for my files. There are other concepts besides of files. Right now, we're not going to talk about this. You could create queues, or you could create tables, or other things. Right now, we're going to be using the blobs. Here you have your summary, all the stuff that you're storing. So containers are folders, similar to the folders in Windows. So you click here, and I see I have all these containers. I have a container for backups, a container for databases. I'll show you that later. You can actually store your SQL databases in the cloud. VHDs, again, these are images that I created from Hyper-V, and I can use them to create new virtual machines. And if I click on one of these, this will show me the content of the container. In this case, I don't have anything. All right, let's see what else we give you. And some information here about how much data I have moved. Like this is the total amount of data that I have moved over time, and average latency, availability, etc. And then, yeah, you can set some alerts. So if, for example, you're storing more than 1 terabyte of data and you want to know because you're going to be charged for that, you can create some alerts and stuff like that. So that's for storage. You can create virtual machines as well. So it's similar. You go new, you go compute, right? And then, well, you have a lot of stuff here. You can go Visual Studio, Ubuntu, SQL Server. Don't use Oracle. It's not very good. So make sure to use SQL Server. Don't type Oracle here. All right. So we have a bunch of SQL Server here. It shows you all the stuff that we have. So you see we have SQL Server 2012, 2008 R2, 2014. We have web, enterprise, standard. We even have some optimized images. So if you want to use transactional workloads, OLTP, you can provision one of these machines. And this already have with a bunch of best practices for performance. So for example, this come with 16 disks. We assign 3 to the log. We assign the rest to data, 12. And then we create storage spaces in Windows so that you can aggregate the bandwidth across all of those disks. And we set SQL memory size and a bunch of trace flags. So it comes with all the best practices for SQL. So anyway, let's say we select what do we want. Select one of these. Enterprise, optimized transactional workloads on Windows 2012 R2. So you create here, and then it will ask you for some data, like the name of the virtual machine, and then the pricing tier. Pricing tier is, again, the size of the virtual machine. It can be very small, or it can be very big. And that's it, very much. Let's see, so, well, these loads, let me show you. Once you go and provision one of these, you get something like this. So you get a virtual machine. And again, it gives you the size. In this case, for example, this virtual machine is an A3. This means it has 4 cores, 7 gigabytes. There is a DNS name associated with the virtual machine, so you can access this machine over the internet with this name. Obviously, you have to open the endpoint for this. If you don't want to access it over the internet, then you just create a VPN tunnel, and I'll show you how that is done. And that gives you information about the CPU usage, I/O usage on the disks, etc. I'm spending a lot of money on this one, so I'm going to hear about that. All right. I guess demos took a lot of time. All right. Let's look at the VPN tunnels. So let's say I have, so in Azure, every time that you go and provision your virtual machines, you can specify a virtual network where to provision the machines. Like this is one example. I have my virtual network here. And this is just like a virtual network in your own network, right? It's just a container of IP addresses that you can use to address the machines inside. Right now, this one doesn't have any connection to on-premises. It's just my virtual network in the cloud. But if I want to go and connect it to my on-premises side, then I click here, side to side, and then I can configure. There's 2 types of tunnels. Side to side means bidirectional communication between every machine. So every machine in my network can connect to every machine in my virtual network in Azure, and the communication is bidirectional. Point to side means only machines in my on-premises environments can connect to my machines in the cloud, and it's unidirectional communication. Anyway, and you give some address space here. So let me show you how does it look once you do it. So once you do it, what you get is a gateway. The gateway is just a piece of software that is running in Azure that accepts connections from your on-premise environments, and it ensures that the connections are encrypted. So you'll see here I have my gateway, and I'm connected it to on-premises. So this is a side-to-side tunnel. And then the way that this works, so the way that you can connect additional parts of your on-premises environment is you go and add new side-to-side tunnels. And the really nice thing that we do is if you want to configure a tunnel to a set of machines in your organization, you click on this VPN device button, right? And here you can select the type of VPN device that you want to use. It can be Cisco, Juniper, Microsoft, etc. The type of device. For example, with Microsoft, you can say I want RAS and what version of Windows you're running. And when you execute that, you get a script, and that script is a PowerShell script. All you have to do is get that script into your Windows Server machine and execute the script. And this script already contains a certificate from the gateway in Azure. And what it's going to do is going to grant permissions to your VPN device to connect to the Azure gateway. And it's really, really simple. I'll actually show you some screenshots of the process. It takes around 20 to 25 minutes in total to set up. But really, it's just download the script, execute it on your side, and wait for the communication to be established. So it's very, very easy. Any questions so far? Yes. It is encoded. Yeah, you can actually. If you don't want to do it as part of the script, you can execute. There's an option to say, no, I don't want it here. You can send it to you to email, for example, and encrypt and all that. Just try to really simplify it. Yeah?
Could you repeat the question that he asked?
Yeah, so the question was, is the certificate encrypted as part of the script that is downloaded? And the answer is yes. All right, so we talk about this. In the end, what we have done in SQL 2014 is add all of these experiences to use this storage and these virtual machines from within SQL Server. So what are the scenarios that you may be interested? So you have your on-premise environment on the left, and you have Microsoft Azure on the right. So the first one is you want to take backups to the cloud. Why would you want to do that? It's a good way to recover. Many companies have these compliance requirements of storing backups outside of the data center, because if the data center goes down or is unavailable for some time, they need to be able to recover the data. So this is a way of doing this. We optionally manage these backups for you. So I'll show you how SQL can manage the backups himself. So you don't have to go and create maintenance plans and management plans and all that. We can do it for you. I like this animation because it took me a little bit of time in the beginning to try to explain it. But you can actually store your databases directly in Azure. So your SQL Server may stay on your on-premises environment, but your databases or partitions inside of your databases can be stored in Azure, right? And I'll show you some examples of why that's useful. Or you can have an always-on configuration. Anybody familiar with always-on? Yes, most people. Good. So you can have an always-on configuration for high availability. So you have your primary and your secondary. And you may want to have disaster recovery, right? Because your environment may become unavailable, because your ISP provider is doing an update on your gateway. So you can have a secondary replica that is available in Azure, and you can fail over to that secondary replica. Or you can use that secondary replica for, yes, question? Yes, so the question is, if you can do always on, can you do cluster? You mean SQL clusters? So SQL cluster is not, unfortunately, not yet supported. We're working on that. So later this year, I expect that we'll support it. Obviously, for always on, you need to configure a Windows cluster. So the Windows cluster can span on-premises and the cloud. So yes, you can do Windows cluster. But SQL cluster, not yet. That's something that we're working on. What is that? Yeah, later this year. Right, so you can have your secondary replica with always on. And I'll show you demos for all of these things. All right, so backup to Azure storage. So any type of backup that you do today, full, differential, log, you can store it in Azure storage. In SQL 14, we have a limitation of maximum 1 terabyte uncompressed. Right? So your database may be larger than 1 terabyte, but the backup itself has to be at maximum 1 terabyte. Backups can be your regular backups that are part of your backup chain, or you can use copy-only backups, right? The ones that are just copies separate from your backup chain, and you can maintain those in Azure storage. And you can restore these backups either back from your original SQL Server, where you took the backup, or from a different SQL Server, or you can even restore it from a virtual machine in Azure, right? So let's say that for some reason your SQL Server has crashed and your media, like your device, your data device is down. You can actually go and restore your backups into an Azure virtual machine, and then you can always move your applications and continue using that. It's kind of a very simple, very cheap recovery solution as well, right? Because you just store the data, and whenever you need it, you provision a virtual machine. It takes around 10 minutes, and then you can continue running your database. For the backups? Yes. Yes. No, sorry, my mistake. The question is, are you going to allow more than 1 terabyte for the backups? The answer is yes. For sure, it's in SQL 2016. We may backport this to SQL 2014 as well. All right, so what are the benefits? We talk about the Azure storage. So again, just a reminder, unlimited low-cost storage. So you can have as many backups as you want. This is offsite. So it's outside of your data center. So whatever happens to your data center, this is separate from that. You don't have to handle the data, the devices, the disks. All of this is logical disks that live in Azure. We handle all of that for you. We talk about the media safety. So we talk about the 3 copies and how if one fails, we have the other copies available. We talk about the copies on the other data centers. So all of that is taken care of. You can encrypt the backups. Right? Starting SQL 14, you can encrypt your backups so that only your SQL Server can decrypt the backups. You can compress the backups as well. Right? So if you compress a backup, it takes around 60 to 65%. So we're always working to try to compress even more. And you can access these backups through many different ways. So sometimes when I talk to customers, they get concerned, how will I be able to access my backups? Well, you can access them through Management Studio, T-SQL, PowerShell. You can access them directly to the Azure portal. So you can go to the website and download it from there. Or any third-party tools, like there is a Cloud Explorer, for example, that allows you to go and look at your Azure storage as if it was just your own NTFS file system. So like you can use all of those ways to handle the backups. You can encrypt the backups with different types of certificates, and you can compress it. Some ideas of how long it takes to backup and restore. So if you use a compressed backup for a 100 gigabyte database, again, this is going to range based on your network. The backup is going to take around 20 minutes. The restore is going to take around 1 hour. Yes? What is that? Right. Yeah. We try to... the question is, why is the restore slower? We have done some more optimizations on the restore side. The backup side today in SQL 14 uses an intermediate process. We use a VDI interface, like a separate process, pushing between SQL Server, the SQL Server engine and the VDI process has some cost associated with that, and that's why the cost is observed there. We're actually removing that VDI interface in SQL 16 so that everything is internal in the engine. So at that point, the backup and the restore process are going to be very, very similar. So the licensing, you can do this through SQL Server. I'm sure that it's a standard in enterprise. I believe it's web as well. So any of those 3 editions, it is supported.
But I have 4 programs.
Mm-hmm.
I have to buy an extra license.
Right.
For the accounting one. Is that structure going to change at all? Or is it going to stay?
The licensing for SQL, you mean?
Right.
In the next version of SQL?
Right.
So it's very unlikely that anything is going to change on licensing. To be honest, that is more of a licensing discussion. I don't have at this point any reason to believe that something is going to change. So don't get worried. So we already changed it before to the per core licensing model. So I don't expect that we're going to change anything at this point, right? And all of these features are available in the standard as well. All right, so we'll talk about what can you do with these backups. So you can restore, either if you for some reason delete a table, for example, you can go and restore that. Or again, a cheap disaster recovery solution. You can use it for dev tests. So if you have a dev or a tester, for example, that want to go and do some work on your database, you can always take a backup, restore it in a virtual machine, and give them access to the backup, right? And they can go and test it. So let me show you the demo for this one. So I have SQL. Can people see well? Is that too small? All right. So we have SQL 2014 here. I'm going to use this database first, just a regular database. So I'm going to use the database. I'm going to select some values from a table. So I have 6 values. Right? At this point, I can go and take a backup. So I could do this through T-SQL. I'm going to be changing between Management Studio and T-SQL in some of these demos so that you can see how it's easy to do it through both. So we can go to the database, and I can say tasks, backup. So this is the traditional backup interface that you have seen before. Right? I can have a full differential, a log. Today you back up to the disk. Right? You store your backups locally. Now you can go and say, I want to store this in a URL. Right? So automatically this generates a name for the backup. I have to select a credential. So a credential is how SQL authenticates to Azure, right? To Azure storage. So in this case, I have a couple of credentials. The first one is a credential for my backups container. I'm going to use this to store that in the container. Remember, the container is a folder. And then I have another one that I'm going to use to store databases later. So right now, I'm going to say I want to store my backups. So in this case, the container, I think, is backups. Let me make sure that is the right name. So you'll see that everything is integrated here. So if I go to my storage account, it's basically the same thing that I'm referring to. So I go to my containers. Yeah, it is backups. So I go back and I say, this is backups. So this is the URL prefix what is going to be stored. Right? Backup options. So I can select compression, for example. Right? So my backup is smaller. I can encrypt the backup. Right? You have all the different encryption algorithms so that only SQL Server can access it. I already created a certificate. I'll show you how you can create it. And then you click OK. And then basically this is generating a backup and storing it. That storage account is actually in, let me show you, it's in West US, so somewhere in California. So I'm sending the backup back to California, storing it there. And if I go and refresh here, you see that I see my backup in the cloud as well. So this is integration between SQL Server and Azure. Right? Obviously, I could go and download my backup from here, or I can use it from SQL. So let's go back to SQL. And at this point, let's say that I dropped the table by mistake. Some table is gone. So if I try to select from it, table is not there. Right? So what can I do at this point? I can go back to my database. I can right-click. I can say restore. Right? So I'm going to restore my database. Notice here, it notices that I have configured SQL Server to use an Azure storage account. So it gives me the option to connect to the storage account. So I connect to the storage account here. And now I specify the device. So this is where I'm going to get the backup from. All right, so I'm going to select again. I'm going to get it from a URL. I click Add. And I have my containers here. Right? All of this from SQL. So I say I want to use this backup, which is in my Azure container. And this is going to go and validate the backup. So it's going to read the backup header. Right? Make sure that restore with header will work, that the backup is fine. And it's going to gather some metadata like the first LSN, log sequence number, the last LSN that is part of the backup, and when was the backup taken from, and all that. Again, this is coming through the West US in California, so it takes a little bit of time. I think this is a 300 megabyte database, so it takes a little bit of time here over the network. But once this comes online, I'll be able to see the metadata of the backup and restore it. Any questions in the meantime? Yeah.
Yeah, in the scenario where you have your data tables in Azure, but your engine is on-prem,
Mm-hmm.
how do you handle or ensure that if there's any kind of network glitches between the two, that you're not corrupting your data?
So the question is, in the other scenario, and we'll talk about it later, where you have your databases directly in Azure storage, how do you ensure that if there is a network glitch, data is not corrupted? So Azure storage works exactly as your on-premises disk. So imagine that you lose connectivity to your SAN, for example. So it's the same behavior. If the transaction is not able to get a commit from the disk where you have stored it successfully, then you won't get an acknowledgement back to SQL. So SQL will return an error. So the transaction never made it to disk. It was never committed. If the transaction made it to disk, for example, as part of the log, but it wasn't applied to the database, then whenever the database comes back online, then it will be applied to the database. We always commit transactions that were committed in the log, but were not applied to databases. And if for some reason it wasn't committed and there was some operation in the middle, then we'll roll back that operation. So it's exactly the same thing as your local SAN. Right? It's just a slower network in the middle. All right, so I see my backup here. I see my files. I could go and change the location of the files so I can reuse them. So I'm going to say overwrite existing database. What else? I don't want to take another log backup. I don't need it. I'm going to just replace the full database. And I want to force to close any existing connections at this point. So what I'm doing, again, is restoring this backup from Azure storage right into my database. And after this, I should go back to my database and just verify that my table is there, right? And I could recover everything. Yeah, so you can do the same thing through T-SQL. So the only thing is instead of saying backup to this, you say backup to URL, right? And you can do it through command line as well. So you can do it through PowerShell, for example. Okay, so it takes a little bit of time. All right, so the database is restored successfully. So now I shouldn't drop it again. Like, oh no, I will be fired then. All right, so you can select the table and then the data is back, right? That's a good way to go and get data. All right, so let's go back to the presentation. All right, so what is coming in the next version of SQL? So the first thing is all of these backups that I show you, they're storing something called page blobs. So Azure Storage supports page blobs. These are kind of random access data blobs. They're very good, for example, to store the disks of a virtual machine. But for sequential writing and sequential reading, as what the backups do, they're first and not most optimal ones, and they're a little bit more expensive. So what we're doing is we're replacing those. Like last year, we introduced in Azure Storage a new concept called block blobs. So we're replacing this. It's actually cheaper. It's 3 times cheaper than the current storage. So it's going to be a lot cheaper. It's going to be some faster as well. We're going to support striping. So you'll be able to take a backup to multiple URLs. So right now, I just took it to a single file. You'll be able to do it to multiple files, and that means that we'll be able to read and write in parallel. So it's going to make the backups a lot faster. And it's also going to allow backups larger than 1 terabyte, right? We'll support 32 terabytes, so very big backup sizes. All right, so for some of you who are not yet in 2014, who is still running 2012, 2008, or 2? All right, so a good number of you. So what we did is we released a backup tool. This is a separate tool from SQL. You can download it from Microsoft.com. And what this does is you give it a directory, and all of the backups that are written there, they are automatically moved to or copied to Azure Storage. The nice thing about this tool is that it supports compression and it supports encryption. So in previous version of SQL, where we didn't support encryption yet for the backups, you can use the tool, and the tool will handle the encryption of the backups. And this works across all the different versions of SQL. So let me show you that one. All right, so I have the tool here. Again, SQL Server Backup Tool. You can download it from Microsoft.com. And you just specify a backup path, somewhere where you store your backups. You can specify a pattern for the files. So I want to copy only .back files or whatever type of extension you use. And you specify the storage account where you want to store your backups, right? And the container, similar to before. And then you can enable encryption and compression. It's very easy to use. Like you click Modify, you specify the path, the file pattern, and the storage account, and the key, and just your password for, this is a password to generate an encryption key that will be used to encrypt your backups, and then you can enable or disable compression. So in this case, what I did is I configured this to copy backups from a local directory. So I can say, take a backup. I'm going to use the same database, but now I'm going to take it to disk. So let me remove this. And I'm going to specify another directory. So I have a directory called backups. And then I can give it a name. So my backup 5.8, for example, .back. Oh, backup. All right. So yeah, it's going to be a full backup. So I'll take the backup. It's going to go into my directory. And then the tool is continuously running as an NT service. And the moment that it detects that there is a new file, it will go and upload it to my Azure Storage account. So again, good thing is you can use this across SQL 2005, 2008, or 2, etc. Right? A good way of handling your backups. All right, so while this finishes, OK, it finished now. So I complete it, and then I can go back to my storage account and refresh. And then it should be there. Oh. Something nice in the meantime that you can do is we introduce an storage explorer in Management Studio. So you see here, you can actually see all the storage accounts in SQL Server. So I can go here to backups, and this is the backup that I just took. Right? You see, it adds a suffix, a unique identifier. This is to guarantee that you don't rewrite any backups in the system. And I have my backup, and then I have, this is just a descriptor of the encryption associated with my backup. And if I go back here, basically you'll see the same thing. So you can look at all of these storage accounts from either within SQL or from the Azure website as well. So you go to website here, and it's the same thing, right? So the same, my backup that I took, all right? All right, so besides of you having to manage the backups, we can manage it for you. So we introduced a new feature called Manage Backup in SQL Server. And this takes backups based on the workload. So instead of you having to specify, I want to take a full backup every 2-3 days, and then a log backup every half an hour or every hour, this was an automated taking the backups based on the workload. So you don't have to go and think about the backup policies. Especially good if you have like 100 of little databases and you don't want to go and handle maintenance plans for all of those things. You can do this. These are the conditions when we take the full backup and the log backup. So full backup when the log has grown more than 1 gigabyte, and then the log backup when it has grown more than 5 megabytes. We have worked with a bunch of customers, and we ended up in those numbers. We ensure a consistent backup chain. So if for some reason a backup is deleted, so if you go and delete a backup by mistake, we will detect that, and then we'll take a new full backup and start a new backup chain. So we'll always guarantee that you have backups to recover your database. And you can specify this for all of your databases in the system or for a subset of databases. So let me show you how this works. Yeah. Yeah. So in 2014 is set. You cannot change it, right? We try to keep it very, very simple. We heard some feedback from some customers that they wanted to have more freedom, so we're actually adding more freedom in SQL 16 for that. Yeah, the question is, will this managed backup work for file stream data? Yes, the answer is yes as well. So when you take the backup, we'll not only take your relational data, but also look into the file stream data. So it will work as well. Again, depending on the size of the file stream data, you just have to be careful of how long it's going to take to move the backup right over the internet. All right, so if we go back to SQL, if I go to this container here, this has the name of my machine. You see I have a lot of backups here. I have a full backup, and I have many different log backups. So these are backups that were automatically taken by SQL using this managed backup feature. So the way that you configure it is, well, if you don't have a management certificate, you can create one. So this is just creating a key for a certificate for encryption of the backups. And after that, you can enable this managed backup feature. You can do it through T-SQL. You can do it through Management Studio. So you use this system store procedure, set DB backup. I specify the name of the database that I want to automatically backup. If I don't specify that, it will apply to all the databases in the system. I enable it with one. How many days I want to keep my backup. So this means after my backup, one of these backups is older than, in this case, 30 days, we have a process that will automatically delete the backup from Azure Storage. So this is to save you cost. This is how do I connect to my storage account, right? When I use the backup credential that I created. The certificate, the encryption algorithm, and the certificate that I'll use to encrypt. And that's it. So I run this for a database. And if you just run this function, all of this is documented in books online. This function will tell me all the backup configurations. So it tells me that it's enabled to take backups to this URL with this encryption algorithm. And basically, this is what it's doing. It's taking backups from this database. So if I want to go and automatically generate a backup, what I have to do is go and insert a lot of data, because that's going to generate a lot of log. So I can go here, and I'm going to use, by the way, I'm using this database, testdb manage. So I'm going to use this database, create a table, and insert 10,000 records, 500 characters each. So I was going to insert, yeah, it's fine. I dropped the table in the end for cleanup. But in the end, this is just, I do that. I drop tables. Just generate a lot of data. So anyway, you see here, the last time that this was taken, like this is basically a concatenation of the date and time. So 5, 8, 10, 26, 21, like that was the last one. And then if I refresh this one, you'll see that there is a new one now here, right? 602. So this was just taken right now. Yeah. Yeah, what is the question? What is that? Compression. Yes, compression is an option, definitely. Yeah, for the backup. So I could do the same thing through Management Studio. So you go to Management in SQL Server, go to Manage Backup, Configure, right? In fact, I think that compression has always, it has to be enabled always. I don't think that we allow this. So you can enable it here, and then you specify the credential and the backup, the encryption. But yeah, I think compression is always enabled by default. How do you find out the container? We actually created for you. So to even simplify more, the container is the name of your server. This is the name that I generated. So if you go back to this one, you see this is the one that is created. So SQL itself creates a container for you. Right? So it's a very easy way for you to manage backups. For, yeah, tell me. Good question. Yes, managed backup is only available to the cloud today. There are questions about whether this will be useful on premises, like to your local disk or your SAN. So it's something that we're looking into. Yeah. Will it be useful, like locally as well? Yeah. Something that we are doing, and actually, let's talk about SQL 16. We allow you to keep a local copy of the backup. So what this means is the last part of the backup chain, so full backup plus a bunch of log backups are stored locally. We asynchronously upload those to Azure Storage. The moment that we take a new full backup, we delete the previous backup chain. But that means that you always have enough backups locally to be able to quickly restore in case that you want to. And then Azure Storage becomes just an archival solution of your backups. So it's a change. Right now in SQL 14, the backups go straight into Azure Storage, right? Nothing stays locally. And we're changing that to give you this station mechanism. And the other thing is we'll give you more flexibility. So you'll be able to specify, I want to take my full backups at noon, or I want to take them, probably not at noon, but like midnight. And how often to take the log backups, right? So we heard that you want more flexibility, so we're doing that as well. All right, so this is a more interesting feature. The first time that we talked about this, like a year and a half ago, people were wondering, like, what is this? It's kind of weird. I tried to use a similar description as Netflix with streaming, your video streaming. And this is like a streaming your databases. And people like, databases is not a streaming. So like, okay, that didn't work very well. So we positioned the feature a little bit different. What we have been working with some customers, and the way that some customers actually found this feature useful is customers sometimes have like cold databases that are very rarely updated. They have to keep them for historical reasons. Like sometimes for compliance reasons, they have to maintain data, for 5, 6 years old. But they don't want to keep it all locally and have to maintain backups and, from time to time make sure that the backups are still working. So for that data that is cold, that is historical, that is not frequently updated, it makes sense to keep it somewhere else. So some of these customers may take like backups to steal like tapes, for example. But if you want to get rid of all of that, what you can do is simply move those databases into Azure Storage. So you can actually store the MDS and the LDF files of those databases into Azure Storage. If you don't have a database that is fully historical or fully cold, like part of the database is still modified, what you can do is you can create file groups, right? And then one file group can be local, right? right? And then all your hot data is there, and the other file group may be in Azure Storage, and that's for the cold data. So you can start dividing this. And again, the advantage is Azure Storage will provide you all of the same things, right? Unlimited storage, the media safety, the U redundancy, and the data is accessible in different ways as well. You can use encryption, so you can use SQL Server encryption, TDE, transparent database encryption, so that only SQL Server can access the data and decrypt it. And you can use compression on the database as well, right, to reduce the size. Yeah. No, so the StretchDB that is coming in SQL 16, the next version, is like a next iteration of this. This is still very simple because you need to manually define these file groups, right? And you specify this is my cold data, this is my hot data, and that doesn't change. I mean, you have to manually go and drop the file group and recreate a new one. StretchDB, from the StretchDB perspective, you have a single database, right? The same concept of database. And StretchDB automatically moves the cold data into Azure. You define what cold data means. So you just say, it's a partition key. So you say, any data that is older than 6 months or 1 year, I want it to move to Azure. And then all the movement, right, is automated by Azure. So it's like a next iteration of this. It's a bit more transparent from your perspective. So let me show you the demos for this one. So go back to SQL. All right, so what we're going to do is, first, we're going to create a new database purely in Azure Storage. So I'm going to specify my data file, right, my MDF. And I'm going to specify my log file. Normally, you will specify a local directory, right, in the disk. Here, I'm going to specify the URL to my container, again, in Azure Storage. In this case, I'm using the DBS container, right? And then this is the names of the files. So I'm going to create my database with the default size. And what this is doing is, this is connecting to my storage account and creating the files themselves as blob files in my container. So remember, all of this is going to California. So it's an interesting way of thinking. Probably not going to work if you have a workload that is continuously uploading the database because you have to pay the latency associated with this. So between here and West US, probably like 40 milliseconds. So you probably don't want to pay that for those type of things. But if you have data that is rarely modified, you still need to keep it, and from time to time do some reads, then it works pretty well for that. So I create a database. If I go to my databases and refresh, I'll see I have this TestDB Azure, which is just a regular database in the system. If I look at the properties, and I see my files, you'll see that my files are stored in Azure Storage, right? Not in the local files. Same thing, you can always run master files and just give you the same information here. All right, so at this point, everything that I do will go all the way to my Azure Storage account. You can also create these hybrid databases where part of the database lives on-premise and part lives in Azure. Right, so I can create my on-premises database. In this case, everything goes to my local directory, right, in SQL Server. So I create this one. And now what I can do is I can add a file group. In this case, I'm going to call it Azure File Group. And I'm going to modify my database and add a file, right, an NDF file, a secondary data file that is living in Azure Storage. And I'm going to add it to this file group. So when I do that, my database is now going to have 2 file groups, one that lives on-premise and one that lives in the cloud. And what I can do after that is, so you can see the database here, hybrid. By the way, if we run the same query as before, you'll see we have the 2 files that live on premises, my data file and my log file, and then I have my other secondary data file that lives in Azure. And now what I can do is I can go and create a table specifically in the Azure file group, right? So any cold data, any historical data, any data that is not modified very often, I can go and put it in this table, right? And any data that is hot, I can put it in a table in the other file group. Yeah, any questions?
What happens when you lose connectivity temporarily to the cloud storage?
Same thing as what happens today with a disk. The query will fail.
So the whole database won't come offline?
The database?
So if I have 3 file groups and one disappears,
Right.
are the other file groups still accessible? Or?
The other file groups are still accessible. The one that is down, it will not. So any queries that you try in the system are going to return with an error, basically. We have a little retry mechanism so that if it's like a little network glitch, which is just a couple milliseconds, you may not notice it. But anything that is higher than 1 second, you're going to get an error on the query. What is that? No, it's not configurable today. We actually have a trace flag to do it. We haven't exposed it yet. The question is, can we configure this retry mechanism? There isn't a trace flag. We just haven't made it public. Will it be useful to know something like that? OK. Got it. So we may think about making a trace flag public. Yeah?
Could I move the MDF up at some point? Like you have a local MDF,
Yeah?
and you have your hybrid Azure file. Could I at some point take the database offline, copy it up,
Totally. Yeah. Yeah, you can.
bring it back online?
You can always move the file groups. Yeah. Yes?
This partition works with this. Can I have a table with multiple file groups across on-prem and the cloud?
Table with multiple file groups, like this one. I mean, this one has 2. Partition table. Yes, you can. I mean, it's the same concept of file groups, just apply it to partitions.
I can do a merge, split them.
Yeah, so from the underlying storage system, all of this looks as regular file groups to the engine. So whatever works with partitions, it will work as well. Yeah. Yeah. Yes?
Will the engine keep the statistics for those remote tables, or are the statistics maintained locally?
The statistics are maintained locally in the same way as for your full database. Yeah. Any other questions? Yes? So it is manual. So you create these file groups. And basically, when you create your file groups, you store the objects on those file groups. You store tables, right, on the file groups. What you could do is, somebody was mentioning, you could create a partition, for example. You could partition a table, and you can specify your partition key. So based on your partition key, that will be automated, right? I mean, you can become more complex if you want. So you can always partition your table and then assign different file groups to the partitions. Yeah, so you can create the rules. All right, so let's go back to the session. All right, so another hybrid scenario that you can do is you can extend your availability groups with always on to Azure VMs. So if you already have, anybody using always on already? I think I asked, but I didn't know if you were using it. Yes, you're using it. OK. So if you're using it today, it's very easy to go and extend those availability groups with replicas that live in Azure virtual machines. Some of the benefits is very, very cheap. I mean, cheap compared to having like a different disaster recovery site. Some customers don't have the disaster recovery site. So if you want to go and create one, you'll have to either pay rent or build one. You'll have to buy the hardware. You'll have to hire someone. So it's a lot of cost. In this case, all you have to pay for is a virtual machine that is running. You have to pay for the storage associated with that virtual machine. All the traffic that you send into Azure is free, so you don't have to pay for the traffic. It's only when you try to get it out that you have to pay for it, right? It has to be like a balance. But again, this works well. Like if it's a disaster recovery site, imagine you have your log being synchronized all the way from your primary to your secondary. So all of that is going to be free, right? If you have a disaster and you fail over to the cloud, and you have, for example, your applications or a copy of your applications living in the cloud itself, like if you have your website living in the cloud, then you don't have to get the data out, right? Like your website is going to read all the data locally within Azure. Right? So
So is that, so basically you're producing a VM, you're putting in the connectors for AD.
exactly.
So basically it looks like a SQL Server there.
It just looks like any on-premise SQL Server. It's just that it's running in a virtual machine in Azure. And you can put this in any of the regions that we have. And we talk about the Azure storage guarantee, no data loss. So the moment that one transaction makes it into the replica in the cloud, the transaction is safe. And again, the virtual machine is highly available. So your secondary will always be running there. A couple of examples. So if there is a disaster, it's a good idea, to be prepared. It may be a real disaster. Actually, a few years back, I remember we had Hurricane Sandy, and I was working with a Stack Overflow. Anybody familiar? Stack Overflow is like a website where people put questions for software development. Anyway, their main data center is in New York. Actually, I have two stories now. So the main data center was in New York, and then Hurricane Sandy hit, and they tried to do as much as they could. At some point, they were actually, I saw photos of the people carrying SQL servers up the stairs, to avoid the water getting to them. At some point, they have to fail over, so they fell over all the way to Oregon on the other side of the US. So they were fine. There was another customer who was not that lucky because they had the main data center in New York and the disaster recovery site in New Jersey. So that didn't work very well. So as soon as that happened, they came to Microsoft like, what can we do? And we said, well, have you thought about doing something like this? And okay, yeah. So it makes sense to have a third disaster recovery site that is far, right, from the main data site. All right, or you can also offload workloads from the primary. So if you have reporting or BI workloads, and they are using a lot of I/O, a lot of memory, you can move them outside of your primary and put them on the readable secondary on Azure, right? Or you can take backups as well. What it takes, what, sorry? Well, it looks just like any other SQL server. It's just that it's a secondary readable copy. So you can connect, for example, reporting services to that as if it was just a regular SQL server. Right? You cannot write to it, but you can read from it. Right? All right, and the only thing that you have to do, we're talking about configuring this site-to-site tunnel. So just showing you how easy it is to do. So when you provision your virtual machine, you have to specify a virtual network in Azure. This is created for you. Once that is created, you have to go and configure that way, the gateway. So you click here on gateway, and then what I show you, you specify the type of the the type of the VPN device. This is a script that is generated. It basically configures your VPN device. The gateway part is already configured. This configures the VPN device so that they can communicate over an encrypted tunnel. And once you run the script, you will go into routing and remote access, and then you can see that there is one of these connections. So it's called a demand dial connection. And basically, this is your VPN tunnel to the Azure gateway. So it's very easy to do. Again, it takes 20 minutes to run, but it's not too difficult. And once you do that, then you can go and extend your always-on configuration. So in this case, on premises, you have something similar to this. You have your availability group, and this is part of a Windows cluster. Right? You have your primary, you have your secondary, and then you have some Active Directory, domain controller, and you have a VPN device. Again, this could be like Windows RAS, for example. And then once you configure the tunnel, you'll have a secure channel to a virtual network in Azure. And inside of that virtual network, you will have a secondary replica. And this will become part of your availability group and part of your Windows cluster. Yep.
So that means you need AD.
You need what, sorry? Yes. Well, you don't need to configure Active Directory here, but you need to join this virtual machine to your domain here. Yep. So once you create a tunnel, these virtual machines look just like regular on-premises machines, and you can ping them or DP to them, add them to your domain, etc. All right. So So let's go back to SQL. So what I have here is one availability group, and this has 2 replicas, has 1 database, right? You can see the availability, the properties of the replicas. So you have 2 replicas configured for synchronous commit, and they are synchronized, right? They are automatic failover. So this guarantees high availability in the system. You have information of the database. So the database replicas are synchronized, and the last time that a transaction was committed, the last sequence number, etc. So if I wanted to add a replica, you go and click Add Replica. And this brings the traditional screen that you have used before. I connect to my existing secondary because I'll need to configure some endpoints for authentication. All right, so before we have this button only, Add Replica, right? We have added a new one, Add Azure Replica here. And this will go and configure everything for you in Azure. So this will go and provision a new virtual machine with SQL Server, right? So you don't have to have the virtual machine. This will do it for you. And then it will add it to your on-premises domain, add it to your Windows cluster, take a full backup, restore it, and then start the log synchronization between the replicas. So you click here. Yeah. What is that? What? Sorry, what? What template? Got it. So I'll show you. You actually choose which one do you want. So I'll show you here. So first thing that you have to do is sign in to Azure from here. So you need to sign on similar to how you do it in the portal. Remember my credentials. And once this signs, it will download all the information from your Azure subscription into SQL Server. So it will show me all the subscriptions that I can use, right? And then here I can select the VM image, the template, right? So we thought originally about trying to automatically detect it and just select it. And then we found that some customers actually change the names of their own images. And if we try to do something small, sometimes we didn't get exactly the right image. So we leave you to select the right one. So in this case, on premises, I'm running actually SQL Server 2016. In Azure, we don't have 16 yet. So the closest thing that I can select is 2014 RTM. So I select Enterprise. I can select the size of the machine. Right? So I'm going to select like a 4-core machine with 8 gigabytes of RAM. The name of the this is the name of the virtual machine. So this is like my Azure replica something, my administrator, my password. Here is the VPN tunnel. So remember, you have to create it before. I have VPN tunnels to Central US, and I have one to West US. I'm going to use one to Central US. I don't change the subnet. I just leave the default one. And here it's asking me for the name of a user in my domain that has permissions to add that virtual machine in the Azure to my on-premises domain. Right? So they need to be part of the same domain. So here I need my password. So let me see if where I have it. Let me see. So I need to copy a password here. And last time, like funny story, in a keynote, like 3 years ago, somebody in the stage, there were like 2,000 people, and he copied for everybody one of the internal passwords in Microsoft. So like there was like a quick call in Microsoft, and we have to change quickly all of our password for that. So after that, we learned like every time that you show a password, you like change the screens. It wasn't funny. He got an interesting, anyway. All right, so you accept here the terms. So I see my Azure replica here. It's a secondary replica. I can specify to be readable, right? I specify network folder where I'm going to share my backup. So that machine in Azure is going to take my full backup from there and restore it. And then I go and do a lot of validation. So we try to validate as many things as we can to make sure that everything works. I mean, we're doing a lot of very complex things under the covers. Adding it to the domain, to the cluster, to the always-on configuration, etc. So we validate all of these things. In this case, this one is because I'm actually using SQL 16 on premises. So it tells me you're using an older version in the cloud, so we don't recommend doing that. But right now, we don't have 16 in the cloud. So, and this is a listener, so I haven't configured a listener to connect to the primary yet. Anyway, you click Next, and then it shows you all the configuration here that you specify. And when you execute it, it'll go and run. It takes around 15 minutes. It's a provision in the virtual machine takes the most time, and then after that, doing the rest of the stuff takes around 5 minutes. Yes? What is that? What? So the question is, what if I already have an existing machine? Unfortunately, today, we always provision a new one for you, so you cannot use the same wizard for that. So you have to use the previous add replica. Right? So you still have to add it to your domain and to your cluster. And once that is done, you can go and add it to your always-on configuration. So we don't do the whole thing for you, but you only need to take care of the domain and the cluster. And after that, we take care of it. Sorry, yes?
How long before you start seeing some of the new Windows containers?
Yes, the question is, how long before we can start looking at provisioning containers? We're looking into that for SQL 16. It's not 100%, but we're looking into that. Any other questions? Yeah. This backup for this replica, you can specify where to put it. It always has to be a network share. It could be like a file share in Azure storage, like an SMB share, or it could be your local network share in your network. All right, so I'm a little bit out of time. I'm going to be here in case you have any questions. Thanks for attending, and everybody have a safe flight back.